Hey guys, I'm going to talk to you about functions today. So if just to kind of make sure we're all on the same page getting started, you should have this note sheet with you. The front of it is going to be, we're starting module 5. So the front of this is going to kind of be a combination of lessons 1 and 2. At the end of me going over this, I'm going to say go ahead and pause this video and stop because I'm going to talk a little bit. It's not going to be nearly as lengthy as the beginning, but on the back of this note sheet, this is going to be what we're doing tomorrow, Friday the 24th. This is going to be about lesson 3, excuse me, which is a breakdown kind of further into what functions are, all right? So just a heads up that I'm going to be talking a little bit about this on Thursday. What is a function at all? What is this? And then Friday, we're going to get a little bit more in depth, and I'll tell you to go ahead and pause. And this is where we'll pick up for the next day, okay? So you know the drill for me teaching on this way. Please pause and write these notes and listen as needed, all right? So I'm going to give you the definition of input, output, what is a function. I'm going to give you an example that I like to teach with, the really short criteria, because this is going to be significantly easier than systems. And then I'll do a couple of these examples, and I'll have you do the last two, okay? So together right now, let's go ahead and start looking at the definition of input and output. That is the most basic part of what a function is. Input and output, to put it very plainly, an input is going to be your x value and your output is going to be your y value. That's truly the basic of what it is. So you've been dealing with x's and y's kind of in tables like this. And if you look at all these tables, you see that input is x and output is y, and they're listed for you that way already. So when we have an input is an x value and an output is a y value, I'm going to read this with you and I want you to kind of follow along with me. It says a function is a rule that assigns each value of one quantity, that's x, to a single value of a second quantity, that is y. Functions may have a formula, but we see them honestly arise in real life situations. So I'm going to kind of get you to picture this and follow me for a second. I like to use the example of a vending machine for functions. And what do I mean by this is I kind of want you to close your eyes and imagine right now that you're putting $1 into a vending machine and you see some cookies you want. And you know you enter in a code for those cookies, right? So let's say the code is B2. And I put my dollar in and I enter B2. That input of the code B2 in the dollar is only going to output cookies. It's not going to output anything else in the vending machine. It can only output cookies because that's the code that's assigned to it. Follow me? So if I input the dollar, I put B2 on the little buttons, I'm only going to get out what's assigned to that column of the vending machine, right? So that kind of leads me to the basic one rule of functions, which is a function. So I put a big star here. This is honestly the most important part of this. A function is correspondence between a set of inputs and another set of outputs. That each input corresponds to one and only one output. So every input can only have one output. When I enter B2 in the vending machine, I am only going to get cookies. So that means when you're going to be looking at these tables of X's inputs, you're going to be looking at, well, it can only have one Y that matches it. And if it has a duplicate, then it's not going to be a function. Okay, so I'm going to bring it all together right now. A function is going to be made up of a list of X's, and we're going to go check those X's, and we're going to see if every X only has one Y corresponding to it. Okay, if we see an X that might have two different numbers that go with it, it's not going to be a function, right? So let's see what this looks like. I'm going to kind of build this criteria here based on this first table. So I'm going to go ahead and look, and this is going to be my first step of criteria. I'm going to go and look and see if my X columns have any duplicates, because if there's no double X's for me to check, it's going to be really easy. I can call it a function because every X is going to have its own Y. So if you zoom in on this right here and say this input of -2, -1, 0, 1, 2, 3, 4, none of those repeat. Every input has its own number output, right? So what I just did was, for this first step of criteria, I looked at the X column to see if there was any repeating numbers. So we are going to look at X column to determine any duplicates, okay, or repeats, whatever word makes more sense to you, okay? If there's no repeats, that means every X is different, every X has its own Y, we call this a function. This can be labeled as a function. Every X has its own Y, okay? If we go to this, and I'm gonna look at table 2 now and say, well, I see some repeats here. I see like 1 and 4, they're repeating. So what I need to do, so where it says if yes right here, I need to go see if those outputs repeat. So I'm gonna go back to the vending machine for a second. I can have B2 as a column of cookies, right? But what if there's another column of cookies, right? I need to know that there's a different input for that output. C2 could be another code for the cookies. So what I'm gonna do is say, well, the only output for 1 can be -1. So if I see any other number that outputs for 1, this is not going to be a function. So I'm going to go check. This is +1. That can't happen. I also can look at 4. 4 has an output of -2. So if I see anything different than -2, not a function. And right here I see +2. So that's also not going to work. So I'm going to label this not a function. Why is it not a function? Because every input does not have its own output. Okay, that's kind of everything for this. I'll finish writing the second step of criteria. So we're going to look at that X column to determine any repeats. If there's none, it's a function. Every input has its own output. If there is some repeats, like we checked here, we can honestly cover these Y's columns every time we start these. And if there's no repeats, it's a function. If we do that here and we see those repeats and we got to check, well, then we have to determine if every input has its own output. Okay, and that's honestly it. I would like you, you can of course pause this and go try these two. Okay, now would be a great time to pause it because I'll obviously tell you the answer. So I want you to go ahead and pause right now, try these two, click play, and then see if you got them right. Okay, give you a second. All right, so I'm going to go through criteria right now and double check. So I'm going to go check right now and see, do I have any X's that repeat? Nothing repeats. There's no reason for me to really do anything else. There are no numbers that are repeating from -2, this. So these numbers don't matter if they're repeating. I can have more than one column of those cookies. I just can't have B2 being more than one thing but the cookies in the vending machine, right? So I am going to call this a function because every input has its own output. Okay, and you can write that right there. Every input has its own output. Okay, and to check this one, I'm going to go ahead and cover up, and I immediately see right here that there are 2 number 1s. So since there's 2 number 1s, I now have to take it a step further, and I have to go check if they are different. It could be the same coordinate listed twice, like if it was 1, 2, and 1, 2. Well, that's the same coordinate. That's okay. That's just a duplicate of the same coordinate. That would be the same output. If it's different outputs, not a function. And I immediately see that these are different outputs, so I can immediately call this not a function. Okay? All right, I hope that this makes sense to you. If you have any further questions on this, this is a kind of a combination of lesson 1 and 2 in module 5, you can email me any questions. I am going to, this is where I'd like you to stop for Thursday. I don't want you to watch any more of the video because this is going to be Friday's notes. This is going to be really, really short for Friday, but I'd like you to watch this fresh after you practice this. So go ahead and pause if it's Thursday so that you can pick this up tomorrow. And now I'm going to focus. So this would be Friday, and we're going to quickly look at lesson 3. So now that we know function, not a function, okay? We can now take it a step further if it is a function. So what we can say is, I need to determine based on inputs or outputs if something is a function or not a function. And yesterday, if you did what you were supposed to do, then you looked at if every input has its own output, then yes, it's a function. And if it doesn't, it's not a function, right? So today we're going to kind of assume that we know that already. We're going to say that we've mastered this and you know that these are two options. I'm going to take it a step further though. And now I'm going to say if it is a function, I'm going to add two more options. We're basically going to say, does it make a straight line or does it not make a straight line? So we're going to say it can be linear, making a straight line, or non-linear, not making a straight line. So in functions, you kind of have three options. It can be not a function at all. Every input does not have its own output. We don't do anything else with it because it's not a function. It could be a function and make a straight line, right? Where the constant rates, I'm tying everything back to 7th grade, and slope, that constant rate or that slope is the same. It makes a straight line, okay? And non-linear, where it would be a function. It passes that test of every input having its own output, but it's not going to be a straight line. I'm going to briefly show you what this means and then kind of let you practice. So this is going to really tie into everything that we've done with slope. And what a nonlinear function, or really not a function at all, is going to mean is that you can never have a straight vertical line, meaning you can't have 0 as the denominator. You've already learned this as being undefined. So if we have these linear functions, then they are going to look something like this, right? Our negative slope, positive slope, whatever it is. And we graph those points, and not only does every input, every x and y matches to make that line, that's all great, then it becomes a linear function. For a nonlinear function, it might be something that is more of these examples here, which you're going to go try. It could be something that is curved, or it could be something that is honestly even a zigzag, okay? But what it can't be, what a not a function looks like, is it can never be vertical. And you learned that with Miss Burat and I as undefined. So it can never be this. It can never be a vertical line, okay? So this is a lot of information in one video, so please, if you have any questions on the Friday stuff, we have a lot more notes in another video link posted for this, talking kind of about if you notice the difference of the exponents and the not exponents there, what those differences are. This to me is the most valuable information. Make sure you have this little graphic organizer here. And if you need to rewatch Thursday's part, go to the beginning of the video. Okay, if you have any questions, you can email me, Miss Jessie.Vincent@apsb.org.